Guys, we're going to be in section 10.2 today. It's on circles. So let's take a look at what the definition is of a circle again, because we want to compare this to the other conic sections that we're going to be getting into: ellipses, hyperbolas, parabolas. We've worked with some of these, but we've never really given the true definitions. Circle, however, from geometry, if you remember, it's the set of points equidistant from a given point. Now, one thing that we have to add on to this is in a plane, because if you don't put the in a plane, instead of that being a circle, that's a sphere definition for space. Set of points equidistant from a given point, that would be a sphere. When we put on that tag in a plane, then that is a circle. So let's take a look. We have two basic forms of a circle that we need to know, and one is called the standard form, and this is one from geometry. So let's take a look at it again. The standard form, that's this: x minus h squared plus y minus k squared is equal to some radius squared. This looks very much like the distance formula. In fact, if you were to take the square root of both sides, you would see that the radius r is just the distance formula between these two. One thing that we want to point out: these values of h and k, all right, if you set this x minus h equal to 0, h, k, this is the center of whatever circle it is that you're talking about. So if you want to find where the circle's starting from, you take both the x minus h, the y minus k, whatever numbers are there, set them equal to 0, and that'll give you the coordinates for both x and y. Let's take a look at example 1 on page 624. It says, write the standard form of the equation of the circle that is tangent to the x-axis and has its center at 3, negative 2. All right? Well, number one, they said it's tangent to the x-axis, and you're at 3, negative 2. So I'm going to come out 3, and then down 2. Here's my center. Well, if you remember back from geometry, if we were tangent to a circle, it meant we just touched it at one point. A secant line goes through it, slices through, hits it twice. But in this case, it just touches. So here is tangent to the x-axis. That's a point that is on this circle. Well, what's the distance right there? Well, that's just 2. Well, if this is my center at 3, negative 2, well, then I've actually got a circle. There's a few more points that I can get fairly easily. We've got the point that's directly vertically above. We can go vertically beneath, and then horizontally left and right, 2 units. So I'm going to go through and mark 2 units here on either side. But I'm also going to come down. And so here's a point that's on the circle. That's at 3, negative 4. The point that's on the x-axis, that's 3, 0. But then left or right 2 units from this center point. Again, these are the easy points to find. Well, this would be 5, negative 2. And this would be 5, negative 1 over here. I'm just going to sketch each of these quarter circles and say that's sort of the circle that's there, right? Well, let's go use the right points here. That's going to be a 1, negative 2. 1, negative 2 there. And you notice going across, they all have the exact same y coordinate. coming vertically down, they all have the same x coordinate, and that's correct now. But let's write the standard form of the equation. They want it in x minus h plus y minus k equals r squared, each of those being squared. So I'm going to take x equals 3, because that's where it's centered. I'm going to take y equals negative 2, all right, and then just go through and set both of these equations in x and y equal to 0. So this is going to be x minus 3, and this will be y plus 2. This is what we'll use now, and we'll take the x minus 3, square it, plus the y plus 2, square it, and now then our radius, which is the 2 right here, we'll take that and square it and write that as a 4. This is the standard form of a circle when they give us the center, and they gave us indirectly the radius. They didn't tell us, oh, the radius is 2. We had to figure that out by saying, okay, I've got to go from that point 3, negative 2, up to the x-axis, because that's where it's going to be tangent, right? Let's take a look at the general form of a circle. Now, the general form versus the standard form. General form we have for all conics, and for the general form for a circle, we have certain things that we look for. And again, this is for a circle. And what we have is x squared plus y squared plus, now look what comes after it, dx ey plus f. So we're going to put that there. Equals 0. All right? And d, e, and f are constants. All right? So there's some numbers being multiplied, coefficients and constant. Notice that the number in front of both x squared and y squared is a 1 right here, and they're both the same. All right? If you had something where they weren't 1s, you could just divide both sides by whatever the constant is, and then you would have different values for the coefficients of x, y, and the constant over here, but you'd still have 0 on the other side. This is what you look for. Anytime that the coefficients of your x squared term and your y squared term are the same, you're going to have a circle, right? So this is what we look for. Let's take a look at example 3 on the next page. And this one says the equation of a circle is 2x squared plus 2y squared minus 4x plus 12y. That's a minus 4x. Plus 12y minus 18 is equal to 0. Okay, now the very first thing that you want to look for is, look at all those numbers. I got 5 numbers there, and every one of them is even. So divide both sides by 2 initially, and come up with x squared plus y squared minus 2x plus 6y minus 9 is equal to 0. Now, once you have this, we've got coefficients of x squared and y squared that are both the same thing, and they're both 1s now, which is what we want. We want to go through and start grouping. So I'm going to bring this negative 2x over here behind the x squared. I'm going to take the 6y and put it behind the y squared. And so this is what I'm going to write. X squared minus 2x, skip a little space, plus y squared plus 6y, skip another little space, and then I'm going to move the minus 9 to the right and get equals 9. Okay? What we're trying to do is get some x plus or minus something squared underneath here, a y plus or minus something squared, and then the number on the right. Well, we've got the number over there. What we've got to do is go back to that method of completing the square, okay? And we're completing the square now with coefficients of 1 here and here, which is a whole lot easier, right? That's the reason why we've got a coefficient of 1. So, method of completing the square, we've got to take half of this x term right here, half of the negative 2, which is what? Negative 1. And then square it, okay? So negative 1, that's the half, squared is plus 1. So I'm going to add 1 right here. And what I've done is I've made this a perfect square trinomial. This we can write as x minus 1 squared, right? We did this in Algebra 2. But since I've added 1 over here on the left-hand side, I've got to do it over here on the right-hand side. I got to balance the equation. I'm adding the same thing to both sides. Well, now we've got to go through and complete the square for the y terms. Again, my linear coefficient, that number being multiplied by the y, is a 6. I've got to take half of it, which is 3, and then square it. And then add that amount to both sides. So this is going to be 3 squared. That's going to be plus 9 here. And then I'll put a plus 9 over here. Again, after we do this, these 3 terms, we're forcing it to be a perfect square trinomial, so we can write it as that binomial squared. This is going to be plus y plus 3 squared, and that's equal to 19. Now, once you have it in this format, they're going to ask, what is the center and what is the what's the center and what's the radius of the circle? Well, let me put it right here. The center, again, if you just take that x minus 1 and set it equal to 0, x is equal to 1. If you take the y plus 3, set it equal to 0, y is equal to negative 3. All right, so we've got the center where it's starting from, our starting point. And now then we've got to go through and find out what the radius is. Because remember, this number that's over here, the 19, that's not the radius, it's the radius squared. So the radius then is just the square root of 19. Now, square root of 19, that's not one of our perfect squares, but we know that this is going to be between 4 and 5 because the square root of 16 is 4 and the square root of 25 is 5. So it's roughly 4.5, all right, just guessing. And so then it says graph the equation, all right. Well, let's pull this down a little bit. We'll get a little bit more space, and let's graph it. There we go. Well, we want to be at 1, negative 3, so that's the point that I want to be centered in on. So I'm going to put this about right here. Here's 1, 1, 2, 3. Here's the center, 1, negative 3. Now, I don't know exactly, that square root of 19, but again, they just want the points. So I'm going to come across to what I think is about 4.5. So 1, 2, 3, 4. All right. I'm going to choose a point right there. I'm going to mark it in red, and now I've got to come down right here. I'm going to put this in red because that's exactly to the right. Well, I'm going to do the same thing on the left. I've got to come over 1, 2, 3, 4. This would be 1, 2, 3, 4. Say 5 is right there. So somewhere about there at that 4.5 mark, and I'm going to put, all right. And I just want to get the coordinates of these 2 points. Well, this is, that's going to be 1 plus the square root of 19, because I'm adding the square root of 19 to my x coordinate from the center point. -3. So I haven't moved up or down for these 2 points. This is horizontal. And this point over here on the left, it's going to have coordinates of 1 minus the square root of 19, -3, right? Left and right, you go whatever that radius distance is, you add or subtract from the x value. Well, then we got to do the same thing for our y values. So I'm going to come up 1, 2, 3, 4, 5. Let's say this is roughly that 4.5 mark. And then I've got to come down. That's 3, 1, 2, 3, 4. Let's say that's 5, and that will be roughly. All right, so here and here are 2 more points. And again, what are their coordinates? Well, the x coordinate now is not changing. But from -3, we're going up the square root of 19, so -3 plus root 19 down here, that's up the radius. And then down here, it's -3 minus the square root of 19. We're going down that radius length. And then we try to make it look like a circle. Freehanding a circle is probably easier than doing little quarters like this, but that's probably the... All right, that's not too terribly bad. It's a little bit warped, but again, if you're doing this on graph paper and you use that same length every time, you should have a fairly good representation of what the graph of that circle will be. All right, and now then, example 4, and this is where it gets hard. Let's take a look at this. It says, write the standard form of the equation of a circle that passes through the points 5, 3. That's 1 point on the circle. -2, 2. And then the last one is -1, 5. It says write the standard form, and what they're giving us is just points on the circle. We've got 3 points. How in the world do we go through and find a standard form just from having these points? Well, I want you to look at the way the textbook does it, because this is a method that will work. Then we're going to look at this a method from geometry, which is, I think, way easier, right? But we want to go through and take a look at both ways, see which one is easier for you to work with. But I'll tell you, the one that's in the textbook takes a long time, all right? Now, if you've got a calculator, you can do some things to shorten your time up. But let's take a look at the very first thing that they do here. We're going to take each of these, and I'll take 5, 3 first. What we're going to do is we're going to plug into the x squared plus y squared plus dx plus ey plus f equals 0. We're going to plug into this general form of a circle, right? Well, when you have 5, 3 up here, all you're going to do is plug in 5 for x and 3 for y. Okay, so I'm going to have 5 squared plus 3 squared. And now then, where we have the d, the e, and the f, we're going to start having some coefficients for 3 variables. So this is going to be, x is 5, so this will be plus 5d. This will be 3 times 3 for y, so this will be plus 3e. And then we don't have anything for f, so that's just plus f equals 0. Well, we've also got to do this for the -2, 2. Well, let's plug in the -2 then for x, the 2 for y. And now this is going to be -2 times d, so I'll put minus 2d plus 2e. And then again, nothing is changing for f, and that one's equal to 0. We've got one more point, and this point is -1, -5. So again, taking these values, plugging them in, -1 squared plus -5 squared. And now this is going to be minus d, and then it's going to be minus 5e plus f is equal to 0. All right? Well, let me erase this now and get it out of the way. Because what I want you to look at, what do we have? We've got 3 equations with 3 variables. And what we've got to go through and try to solve for are the d, the e, and the f. All right? How do we do that? It's a system of equations. So let's go through and change these values now. This 5 squared, that's a 25 plus 9. The -2 squared, well, that's just a 4 plus another 4. And then for the last one, this is going to be, 1 plus 25. So we'll just put this in. All right. Well, again, these constants up front, these will combine. So I'm going to take each one of these. And now then, take the 25 plus 9, add it together, that's 34. But I want to move it over to the right-hand side as a -34. I want to take the 4 plus 4, that's an 8, and move it to the other side of the equation now, which is a -8. And then finally, the 1 plus 25, which is 26, move it over and make that a -26. Now, in these 3 equations, we've done this, it's been a while. How do you go through and set up a system of equations to solve for these 3 different variables? We can do it by hand. All right. Hand takes a little while. If you'll notice that the e's right here in this middle column, if you were just to add these together, the e's would drop out. And that would be nice. That would leave you with only d's and f's. All right. We would have to come through and have another e drop out from a couple. So this is where matrices come in. Do you remember the matrix? All right, going through and solving using matrices. This is what they do, and it all the direction. Look on page 626 here. What they say to do: simplify the system of equations, and they leave the constant on the left-hand side instead of moving it over. But then they say the solution to the system is. They don't go through any steps, no steps at all. So they just expect you to be able to do that. That's kind of nice. I'm not going to go through and do that here. What I want to go through and show now, because you can do that once you use your matrix methods. And on this, I would expect you to use a calculator, plug in the 3x3, plug in the x, y, z, and then plug in the variable matrix and go through and solve for that. But let's take a look at the geometric way to do this, because it's also a very nice, and I think it's a little easier to understand, method. Let me scroll this down twice. All right. All right. Now, for me, I want to look at where these points are on the graph, because there's something that I remember about circles and points on the circle. Well, let's see, 5, 3, 1, 2, 3, 4, 5, up 3. Here is a point that is on the circle. There's 5, 3. Well, I'm going to put -2, 2. -2, 2, Same distance, so about right here. There's negative 2, 2. And then finally, negative 1, negative 5. So 1, 2, 3, 4, 5. This will work much better with graph paper as you're doing it on your own. And here's the negative 1, negative 5. That's up a little bit more than it should be, but we'll leave it. All right, I'm going to connect from here to here. Now, if these points are on the circle itself, then this is a chord. That's a chord of a circle, all right? And if I were to go through and make the perpendicular bisector, and again, if you've got something like, oh, I don't know, GeoGebra, where you can go through and construct a perpendicular this very quickly, why, you will get, and I'm going to just guess here, this is not the GeoGebra, but let's say that's a perpendicular bisector, okay? Yeah, 1, negative 5 down here. I put a negative. It's supposed to be positive. Oh, so I've got to be over here. Let me get it in the right spot. This is where it's supposed to be. All right. Well, see, this perpendicular bisector that cuts that chord is going to go through the center of the circle. It will always pass through the center of the circle. It's slicing the circle into 2 equal halves when you do that. Well, if I connect another point on the circle to this point on the circle, that's another chord over here. Again, if I go through and I just construct the perpendicular bisector of this, and I am, all right, something like this, the point where these perpendicular bisectors meet is the center of the circle, all right? And then, once you know where the center of the circle is, how do you find the distance to any point here? You can use either the distance formula, you can use a Pythagorean theorem setup, all right? But see, this is going to work for all 3. See, this looks like a triangle, and this may actually be on that side of a triangle, the way that they have it set up. If you'll notice, the center of the circle that they have is 2, negative 1, all right? So they're telling us that this point is at 2, negative 1. Now, that's almost, even with a diagram this bad, if this had been on graph paper and actually done nicely, you'd see it's right at 2, negative 1, all right? And then once you want to get the radius, well, you would just go through and from 2, negative 1, count up to one of the points, find out what the side lengths are. Well, that's a 3 from 2 to 5. It's a 4 going up from negative 1 to 3. And if you remember our Pythagorean triples, that's a 3, 4, 5. The 5 is the hypotenuse of that right triangle. That's the radius of the circle. So again, using geometry, you can find this center point possibly in an easier method than going through and doing the system of equations. Now, when to use which one? If you don't have a graphing calculator so that you can go through and set up matrices, you don't do it that way, all right? This way is going to be easier. If you do have access to a graphing calculator where you can set up the matrices and have the calculator do it for you, you're probably going to do that, okay? Because all you have to do is input the data, all right? These coefficients of D, E, and F, that's all you have to do. Once you have that plugged in, you're going to use your matrix multiplication to solve for what are D, E, and F, plug those values in, and then convert it back. You still have to convert it back to the standard form which is the x minus h squared plus y minus k squared is equal to r squared. And that, example 4, is really what makes this section a little bit difficult, because we've got one or two of these that we have to do and solve. And so for me, I'm going to be taking GeoGebra if I have access to that, and I'm just going to use it. But if I don't, I need to be able to do both. All right, do the geometric, do the matrix methods, because they're both useful. And that's it.